In section 3.8 we're solving trigonometric equations. First thing we're going to look at is if we have this in some sort of a quadratic equation, we're solving from there. Remember, first step here would be to have this set equal to 0. We want to make sure that we have it set equal to 0 so that then we can factor our quadratic. And then once we factor, now we're solving for each quantity. So we're going to do a couple of examples here. First example, say we have 2 cosine squared theta minus 1 is equal to negative cosine theta. Again, we said first step is to set it equal to 0, so I'm going to add the cosine theta over to this side. So we have 2 cosine squared theta plus cosine theta minus 1 equals 0. Now we can think of this as 2x squared plus x minus 1, if that's going to help us with our factoring. And just substitute x in for our cosine value. So here we'd have an x squared for the cosine squared theta, and here's an x for cosine theta. And now we're factoring. So this would, we have our two quantities. 2x and x gives us our 2x squared. To get a minus 1, we're going to have a minus and a plus. To have this be positive in here, that means we're going to have the minus 1 plus 1, so that when we FOIL we get a positive 2x and then a minus 1x to give us plus 2x plus 1x in the middle. So now we're going back to say 2x minus 1 equals 0 or x plus 1 equals 0. So here we're solving to say x is equal to 1/2. Here x equals negative 1. Now remember, we substituted right back here at the beginning, so now coming back, we're saying that the cosine of theta equals 1/2, or cosine of theta is equal to negative 1. Now from this point, now we're using our unit circle. We know that cosine of theta is equal to 1/2 at the angle pi over 3 and 5 pi over 3. And we know that cosine is equal to negative 1 at pi. So if we're just talking about one time around the unit circle, we have these three angles. That would make up our solution set. In this example, we have sine of 2 theta times the sine of theta is equal to cosine of theta. Again, solving here, we're going to again set this equal to 0. So now we have sine of 2 theta times the sine of theta minus cosine theta equals 0. Now something else we can use when solving these is we can use the identities and we can substitute some values in. So instead of sine of 2 theta, I know that's equal to 2 times the sine of theta times the cosine of theta. So I'm going to plug that in for sine of 2 theta. We're still taking that times sine of theta from right here, have our minus cosine of theta. This is all equal to 0. Now one thing we can do here is we can factor. Now as far as having our sines and our cosines all together here, we won't be able to solve for anything like that. We'd need to have just one trig identity in a quantity to be able to solve this. But if we factor out a cosine, so now I have, let's see, 2 sine theta times sine of theta. So now we have 2 sine squared theta minus 1 when we factor out the cosine here and here. And this is all equal to 0. So now we have our two quantities. And so from this, now we can set each quantity equal to 0 and then solve. So we're saying that cosine theta equals 0, or 2 sine squared theta minus 1 equals 0. And now we solve for theta in each of these. So cosine of theta equals 0. Again, go right to our unit circle. So theta is equal to pi over 2 or 3 pi over 2. Here, we're going to solve for theta. I would first add the 1, then divide by 2. So we have sine squared theta is equal to positive 1/2. Now we're taking the square root of both sides. So sine of theta is equal to the plus or minus the square root of 1/2. We can simplify that. Square root of 1 over the square root of 2. So now we're saying plus or minus, if I rationalize the denominator, that becomes square root of 2 over 2. So we have sine of theta is equal to plus or minus the square root of 2 over 2. Now we're looking on our unit circle, where is sine equal to those values, and we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So for this problem, our solution set would include pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4 for all the possible angles that would make that true. So in that last example, we used identities as part of solving that as well. Again, we set it equal to 0, and when we're talking about rewriting with one trig function, that'll typically be either sine or cosine. But we want to rewrite these if possible with one trig function, or at least separate our quantities so that we only have one trig function in each quantity. And we're going to use identities to do substitution to be able to help us solve those. So in this example, we have 3 minus the sine of theta is equal to cosine of 2 theta. So again, what we want to do here is we want to set this equal to 0. So 3 minus sine of theta minus cosine of 2 theta is equal to 0. Now we know cosine of 2 theta is also equal to 1 minus 2 times sine squared theta. So if we substitute, and we're subtracting that quantity, it's minus cosine 2 theta. So I'm going to rewrite this as minus the quantity of 1 minus 2 sine squared theta that I'm substituting in for the cosine 2 theta. Now, remember, this is basically going to distribute a -1 to each of these. So as we rewrite that, 3 minus sine of theta, I dropped the theta there, minus 1 plus 2 sine squared theta equals 0. Remember, this is basically a -1 going to both of these. That's why I changed the sign right there. So now if we rewrite this, let's put it in order more like a quadratic. So we have 2 sine squared theta minus sine theta. Then we have a positive 3 and a -1, so that gives us plus 2 equals 0. So now let's see, 2 sine squared theta minus sine theta plus 2 equals 0. Well, let's see, if we think of this as 2x squared minus x plus 2 equals 0, there isn't any way that we can factor this. So what we could do here then is use quadratic formula. So we've got our a, b is -1, c is 2. So as far as solving for x, we're going to say that x is equal to 1 plus or minus the square root of 1 squared minus 4 times 2 times 2. All of this is over 2 times 2. So there we're using quadratic formula to solve here. So this would be equal to 1 plus or minus square root of -15 all over 4. So what this means is there's no real solutions. In this example, we're going to use our calculator to help us solve this problem. Here we have x is equal to 4 times the sine of x. So we can think of this as in two different ways with our calculator. We can either write this as y equals, and then I'm going to put this on one side, so we're going to subtract the 4 sine x over. So we have y is equal to x minus 4 times the sine of x. And we could solve it that way in our calculator. Remember, we would have to have y equals to be able to graph this. The other option is to say y is equal to x. That takes care of this side. And then we could also have y equals 4 times the sine of x. That takes care of this side. And graph the two lines. So in this scenario, we're going to be looking for our zeros. In this scenario, we're going to be looking at the intersection of the two lines. So let's go ahead and graph those on a calculator and see what that looks like. On this first example, I'm going to do x minus 4 times the sine of x. I've set my window from -5 to 5 for both x and y. I've already plugged in x minus 4 times the sine of x. I am set in radians on this. So now when we look at the graph, again on this one we have one equation for this, and so now we're going to be looking for the zeros as we work our way through this. So what we can do is we can calculate, we can find zeros that way, in which case we have one here at 0, 0 we can see. We can also scoot this over and we can see it's going to cross right here as well. So I'm going to hit the left bound, I'm hitting enter, and now I'm going to go right bound, hit enter. So it's going to find my 0 in between those two values, and it just found that for our x values at -2.47. We could do the same thing on this other side to find our 0 there. On the second example, now we're going to plug in the two lines. We have y equals x, and we have y equals 4 times the sine of x. Again, plug that in. Still have my window set the same way, -5 to 5 for both x and y. Still in radians. So now when I graph, here's my y equals x line, and then here is y equals 4 times the sine of x. So now this time we're looking to see where they intersect. Well, it looks like they intersect at the origin, which if we think about the line y equals x, and if we think about the line y equals 4 times the sine of x, they would both go through the origin. Now we can also then look and see where our intersections are on either end here. So again, if we go to calculate, and I'm going to hit 5, so that's the intersection. So the first curve that I'm choosing, I'm going to pick our line y equals x. And then the second one, I'm going to scoot down there to the y equals 4 times the sine of x. And now it's going to guess for the two of those. I hit enter, and it's going to my point there where, again, x is equal to -2.47, just as we had before.